बिस्मिल्लाहिर्रहमानिर्रहीम। एक्सरसाइज 3.5 है, पेज 91 है, मैथमेटिक्स है, नाइन्थ मैथमेटिक्स और की पी के हैं, टेक्स्ट बुक है, नाइन्थ क्लास मैथमेटिक्स की पी के टेक्स्ट बुक है। क्वेश्चन नंबर 1 है, यूज लॉगरिथमिक प्रॉपर्टीज टू सिंप्लीफाई द फॉलोइंग एक्सप्रेशन। लॉग ऑफ अंडर रूट 7 ऑफ अंडर रूट 7। तो इसकी वैल्यू हमने फाइंड आउट करनी है। लेट कंसिडर, लेट से एक्स इज इक्वल टू लॉग अंडर रूट 7 ऑफ अंडर रूट 7, और वी कैन आल्सो राइट log of under root 7 with respect to base 7 equal to x. So by definition of logarithm, we can say under root 7 of x is equal to under root 7. In logarithmic form, we can say that log with base a of x is equal to y. So when we will have to change into exponential form of logarithm form, तो double implies if and only if e raised to power y equal to x हमारे पास होता है. That is the logarithmic definition of a log. That is logarithmic form of a definition of a log, that is the exponential form of a log. Clear? So by means of this we can write the value of we can find out the value of x. So for this we have to simplify the exponential log 7 whole raised to power 1 over 2 of x equal to 7 whole raised to power 1 over 2. So by exponential law, if we have e raised to power m is equal to, or we can say that 7 raised to power x1 are x divided by 2 is equal to 7 raised to power 1 over 2. We can say that by means of exponential law, if e raised to power m is equal to e raised to power n, so we can compare its powers like m is equal to n. So by this we can compare the power of the above exponents. So x divided by 2 will compare to 1 over 2. So when we will have to multiply 2 with 2, then we will get only x. So multiply 2 on both sides. To find the value of x, we can say, so we get x is equal to 1, which is the value of unknown x given in the exponential form. Okay, now goes to the next question. Here next question, log with base 8 of 1 over 2. Solution, let's say log with base 8 of 1 over 2 equal to x. So by definition of log, 8 raised to power x is equal to 1 over 2 by definition of log. Clear? So if we have 2 raised to power, we can write 8 2 raised to power 3 whole x, or we can say that 1 over 2 2 raised to power negative 1. If we have 1 over e raised to power m, that is here 1, so we can write it e raised to power negative m by exponential law. Okay, so we have 2 raised to power 2 3 2s are 3x are 3x and 2 raised to power negative 1 by means of exponential law. If we have 2 raised to power m and 2 raised to power n, bases are same, then we can compare its exponent. So m equal to n. So by this definition we can say that 3x is equal to negative 1, or 3x 3 is the coefficient of x, so we will have to remove it from here by opposite operation. So here is multiplication, so we will have to divide 3 on both sides. So 3x divided by 3, negative 1 divided by 3, so we get the value of x, which is negative 1 over 3, which is the required answer of unknown x. Next we move for another question, which is third one part of the given value. Number 1, log with base 10 of under root 1000. Solution, let's say log with base 10 of under root 1000 equal to x. So by definition of log, 10 raised to power x is equal to under root 1000 by definition of log. When we will have to change a logarithmic form into an exponential form, we can write e raised to power x is equal to y. So we can say that e raised to power x is equal to y in logarithmic form, e raised to power log with base log with base a of log with base a of log with base a of y is equal to x. We can also change it this form. Okay, this is if and only form. So here we can write this as a roughly note. So 10 raised to power x remains same. Here 10 cross 10 cross 10. So then we can write that 10 raised to power 3 whole 1 over 2. Radical sign value is a radical sign value is a 1 over 2. So we can write. So if we have x raised to 10 raised to power x equal to 10 raised to power 3 ones are 3 divided by 2 हो जाएगा. Now here by means of exponential law, if we have 10 raised to power m and 10 raised to power n by means of exponential law, so we can compare easily m equal to n. So 10 and 10 are equal. Then we can compare x is equal to 3 by 2, which is our required answer. Now move to the next question. Here is fourth one. Log with base 9 of 3 plus log with base 9 of 27. So by definition of log, if there is sum between the two logarithmic values, we can change it to its product. Log with base a of m plus log with base a of same base n. Then we can write log with base single with respect to a m multiple n. This was the proof of first rule of logarithm. So we can use here. यहाँ पे हम logarithm को हम क्या कर लेंगे, सिंगल कर लेंगे. So by means of this definition, so we can say that log with base a here is 9. A is equal to 9. So we can write log with base, that is solution, log with base 9 of 3 multiple 2 7. We can also write log with base 9, and we can also write in this form 3 multiple 27. It means we get 81. Now let's say log with base 9 of 81 equal to x. So by definition of log, we can write a raised to power x is equal to y. Same by this definition, a raised to power, so sorry, log a raised to power x is equal to y. So we can change into exponential log a raised to power y is equal to x. This is definition. So 9 raised to power x is equal to 81. Make its base 9 raised to power. So 81 can be written as 9 raised to power 2. 9 multiple 9. So by means of exponential law, x is equal to 2, because we know that e raised to power m equal to e raised to power n. So we can write m is equal to n. This is the solution and answer. Next question is V. Log with base 1 over 0.0035 whole raised to power negative 4. Solution. Let's say x equal to log 1 over 0.0035 negative 4. X equal to here if we have two amount which are in division, numerator and denominator, and we apply log, common log, so we can say, we can write log with respect to a of m, symbol of subtraction, log with base a of n by definition of log. So second definition of log, the second rule of log. So that is m, or that is a as a whole of n, where the exponent, that is m, that is a 0.0035 whole negative 4, that is whole of this part, or this is whole this part. Okay, log with the 10 of 1 base, here is a 10 which is a common logarithm. We can हम इधर commonly इसको लिखते नहीं है, तो ये मेरे पास 0 दे रहा है और माइनस. So log with base 0.0035 whole is to power negative 4. Here we can also use the another definition of log, which is the power rule. Log with base a of m whole n. We can write m whole raised to 1. If we have minor amount or major amount whole raised to power n, then n times its exponent, n times of log with base a of m. So we can write here negative 4 is a n, that is 0. There is a symbol of negative, which is by formula So negative 4 is here to represent the n, or log with base 10, 0.0035. Clear? Negative with negative positive, 4 log with base 0.0035. So also we can write this as an answer. If you do want to solve it, so further we can also solve it here. If we will have to solve it for the unknown value of x, so 4 times of log here, find the value of log. So for log, first of all we will have to write it the given statement to scientific notation. So scientific notation is from left to non-zero element we 3, and we will have to put here a decimal point corresponding to power from left negative 1 and negative 1, so negative 3. So here character is negative 3, and mentisa have to find, which is first of all we will have to check 35 from left, that is um, useless zeros, doubtful zeros, not considered as a significant figure, so we can write 35 only. So put here 0. You can also put here another 0, but in logarithmic table we have a difference column which takes start from 1. So here if we will have to put 0, which is useless. So in logarithmic, first of all we will have to first 2-digit numbers from left to right, non-zero 2-digit number, check in the column of 0. So here is a logarithmic table 35. Here is a 35. This is our 35 digit under 0. So this is our 0 column. So 35 under 0 is 5441. 5441 with a decimal sign, a decimal point, which is must for Mantisa in logarithmic table. Now log of x is equal to log of something value 4 times. So we can write log is the sum of value. We can write is the sum of character plus Mantisa. So 4 times of here character is negative 3. We can also write here plus sum of Mantisa 0.5441. So we can write 4 times of negative 3.5441, which is our answer. If you can also further, then we can multiply the given statement to get the more simplified answer. So next question will be, which is the last question of the question number 1, which is sixth one. So here log 45 solution. Let's say log 45, which is 5 multiple 9. We can also write 5 multiple 10, 5 multiple 9, 5 multiple 10. You can write 15 multiple 3. You can also write here. So due to lack of space and time, I'm going to write this. So here is the product between the two amounts. So by definition, log with base a of m plus log with base a of n. We can write here like so. So it is a symbol of equation, not implies. So we can further also can write here log with base a of 5 log with base 3 raised to power 2. First of all, here we have used log with base a of m multiple n. This was given format, and we will have to write log with base a of m plus log with base a of n. This was required. Okay. So log with base 5 with 10 of 5 remain same, and here it is m raised to power n. So 2 times of log with base 10 of 3. So I used the third rule, which is log with base a of m whole n. So n times log with base a of m. This is the required answer if you would like to solve it. So we will take the log of 5 and log of 3. We can also find out from logarithmic table. So this was required. So here we take a tea break. Inshallah, meet in next video and next day. Thank you. Allah Hafiz.